In this video, I want to consider solutions to exercise 1 on kinematics. We'll start with solution to question 1. Solution to question 1. The question 1 says the load is moving at an initial speed of 90 kilometers per hour. So the initial speed is 90 kilometers per hour, which is, if you reduce very well there, over 1 hour is 3,600 seconds. 18 day to 18 day, this will be 25 meters per second. And the driver applies brakes to bring it to a stop at a distance of 20 meters. And S is 20, the final speed is 36 kilometers per hour, which is 36,000 meters over 3,600 seconds. This reduces to 10 meters per second. So the initial speed. So calculate the further distance that was traveled before the lorry came to a stop. So how do you solve that? So we apply this equation: v squared is equal to u squared plus 2as. So finally, in this phase, over a distance of 20 meters, the final speed was 10. So we squared there. The initial was 25. We squared a plus 2a, then over 10. So we have to calculate the deceleration. Deceleration is uniform. Acceleration is uniform. So I want to calculate the further distance that was traveled. So 10 squared is equal to 25 squared plus 2 times a times 20. So we have 100 minus 625 is equal to 40 over 40 over 40 there. If you calculate very well there, you should get your deceleration as 13,125 meters per second squared. That is, it is negative acceleration, which is deceleration. And the x has been applied, so the word was decelerating. So to calculate the further distance traveled, we go back to our equation: v squared is equal to u squared plus 2as, which is the final speed should be 0 at stopping. The original speed is 25. Then the deceleration is 13, the acceleration is 13,125. The total displacement, yes. So if you calculate very well there, you should get your total displacement as 23,81 meters. This was the total displacement. But the further distance that was traveled after traveling 20 meters, and the further distance, therefore, further distance that was traveled before stopping. Further distance traveled is equal to 23,81 minus 20, which is 3,81 meters. That was the further distance that was traveled. Now we move on to solutions to question number 2. It says that a driver is driving at 90 kilometers per hour. So the initial speed of the driver is 90 kilometers per hour. Solution to question 2. So the initial speed is 90 kilometers per hour, which is 25 meters per second. The total displacement, the driver is 40 meters away from the barrier. The reaction time is equal to 0,757. This is the time over which the driver has decided whether to apply brakes or not, right? So after 0,757 seconds, the driver applies brakes. So for what is called the thinking distance, the distance over which the driver is responding to, is deciding to apply brakes. The thinking distance is initial speed times reaction time, which is 25 times 0,75, which is going to be 18,75 meters. This is called thinking distance. So after having decided to apply brakes, we are going to apply what is called the braking distance. Braking distance. So we apply v squared is equal to u squared plus 2as. So the final speed should be 0, the initial was 25, then the deceleration accelerated decelerated 10, so the acceleration is minus 10. So the total, the braking distance, this is the braking distance. So we'll have over minus 20 over minus 20. So the braking distance is going to be 31,25 meters. So the total distance traveled is thinking plus braking, which is 18,75 plus 31,25, which is 50 meters. But the driver is 40 meters away from the barrier. Therefore, the driver struck the barrier. So the total distance that he traveled is 50 meters. Now moving on to question 3. Solution to 3. Solution to question 3. Solution to question 3. A driver is driving at 10 meters per second. So the initial speed is 10 meters per second, right? Is 15 meters away from the stop line. The driver's reaction time is equal to 0,88 seconds, right? Reaction time is 0,8 seconds. And so thinking distance is U times reaction time, which is this. So it will be 10 times 0,8, which is 8 meters. So the driver should finally brake. So the braking distance is from v squared is equal to u squared plus 2as. So 0 squared is equal to 10 squared plus 2. It decelerates uniformly at 10. So the acceleration is minus 10. So this is the braking distance, which is, so braking distance is going to be equal to 5 meters, right? So total distance traveled. Total is going to be braking plus thinking, which is 5 plus 8, which is 13 meters. So the driver traveled total displacement of 13 meters from the time you saw the brakes. So it will be 2 meters away from the stopping line. So he was not involved in an accident. The driver stopped at 2 meters before the stop line. Did not get involved in an accident. Right. Now moving on to solutions to question 4. Not involved in an accident. Did not get involved in an accident. So solution to question 4. Solution to question 4. The driver is driving at 40 meters per second and sees a speed limiter. So the initial speed is 40. Speed limit is equal to 36 meters per second. Reaction time is equal to 0,6 seconds. Right. Reaction time is 0.6 seconds. Reaction time is 0. The driver applies brakes and deceleration from the 10 meters per second. So you can find out whether the driver breaks the road rule or not. So, thinking distance is equals to u times this initial speed times reaction time, which is 40 times 0.8, which is 40 times 0.6, which is 24 meters. That is the thinking distance. Then the braking distance. So it's v squared is equals to u squared plus 2as. So the driver must reduce the speed to 36. Initial speed is 40. The acceleration is minus 10. So this will be our braking distance, right? So if we apply this equation, block proper to get the braking distance, it's very simple. What is our braking distance? Braking distance will be equal to 36 squared minus 40 squared over minus 20, which is going to be calculate the room, get 15,2 meters. So total distance will be thinking plus braking, which is we said our thinking distance is 24, our braking is 15,2, this will get 9,2 meters. So the driver moved the total displacement of 9,2 meters, so it did not breach the rule. So we was 10,8 meters away from the limits, from the speed limit sign. Limit sign when we reached a speed of 36 meters per second. So the driver did not break the rule. Now let us move to the final question, number 5. The bus is moving. Solution to number 5. Solution to question 5. The bus is moving at a constant speed of, so the initial speed of the bus is 40 meters per second. The bus and moves past a stationary car. So after 5 seconds, the car takes off. So the difference between the time of the bus and the time of the car is equal to 5 seconds. The car takes off and accelerates 8. So the acceleration of the car is 5 meters per second squared. That is the car's acceleration. The acceleration of the bus is 0 meters per second squared. So the bus has moved at a constant speed. So the car takes off and accelerates uniformly at 8 meters per second squared. The car's acceleration is 8 meters per second squared. So after 5 seconds, the car took off. So the difference between the time traveled by the bus and the car is 5 seconds. Calculate the distance traveled by the car before overtaking the bus. So it's saying for the bus, initial times, right? For the car, half acceleration of the car times time of the car squared. So for the bus is 40, then for the car it's half times 8 times, which reduces to 4 times TC squared. This is the equation of motion for the car, the displacement of the car, right? So we want to calculate the distance traveled by the car before overtaking the bus. We have agreed that the distance traveled for the bus is 40, for the car is 4. So at overtaking, distance traveled by the bus is equal to displacement of the car. So this is going to provide us as a solution to the displacement traveled by the car at overtaking. Right? And we have agreed that the difference between the time of the bus and the time of the car is 5 seconds. Agreed. So let's quickly solve that. Let's quickly lay down the solution to this. So our solution is simple. S bus is 40, then for the car is 4. So what the time traveled by the car? So we'll say we'll eliminate for the bus and say 5 plus t for the car. Then we'll have an equation like this. Equation like this. Which is going to be 4 TC squared. Right. So here we eliminate for the bus and say 40, 5 plus t car is equal to 4 t car squared. So we have an equation like this. 200 plus 40 is equal to. So we reduce this equation to a quadratic equation in terms of t, which will be minus 40 minus 200 is equal to 0. So this equation we divide by 4 there, it reduces to minus 10 minus 50 is equal to 0. So we should solve this equation for the time taken by the car. The time after which the car overtook the bus. So this will reduce to minus 10. We'll apply quadratic formula, which would be minus 10 squared minus 4 all over 2 times 1. So the time for the car there would be 13.66 seconds. So the car overtook the bus after 13.66 seconds. Right? So the displacement traveled by the car. Will be half acceleration of the car times, which would be half times, we said the acceleration of the car is 8, the time there is 18.66 seconds. So total displacement should be 746.38 meters. So the displacement traveled by the car before overtaking the bus is 746.38 meters. Or you can say 746.4. That is how basically this is solved. So thank you.